find the inverse, is the derivative of the inverse at 2. So we want to find the derivative of the inverse at 2. Right? So that's what we want to do. So if we follow that formula, it was something like 1 over
f prime of the inverse of f, I think?
yeah, g of x. So this, the problem with this here is if we set this up to find the inverse, we got to let x equal y cubed plus 2x or 2y minus 1. Right? This, how are you going to find the inverse of that? How are you going to solve that for y? So the formula, we go with the formula, or looking at this, I'm thinking we could take the derivative of this function implicitly right here, couldn't we?
That's what Dolphin said.
So the dolphin said that it's got to be true.
Yeah.
Like we could take the derivative of this with respect to x implicitly. And derivative of x with respect to x is 1. It would equal 3y squared dy dx. Right, plus 2 dy dx. Plus, minus 0 or plus 0. So factor dy dx out of both of these and then divide by 3y squared plus 2. And the derivative of y with respect to x. Let me I'll go and show the steps. I factor that out and I'm left with 3y squared plus 2. Right, equals 1. I'm just bringing
Plus 2.
yeah, plus 2. I'm just bringing this over there. Taking 1 and want to write 2. Right, so then the dy dx is 1 over 3y squared plus 2.
And that's the derivative of the inverse?
Yeah.
Because you swap the x and the y?
Yep. Yep, so we took the derivative of this. This function would have been our inverse if we solved for y.
So it's easier to find the derivative of the inverse than it is to find the inverse itself?
Well, that one I don't know how you find the inverse.
Isn't that
what
the
I
way
said
to
just
do it?
Well, let's one thing at a time. So you're saying this right here, that is actually the derivative of the inverse, right?
Yes.
Is 1 over 3y squared plus 2.
Is it not 3x squared plus 2?
No, it says 3y squared, right?
Yeah.
It's we switched the x and y, right? Found the derivative of y with respect to x. If we solved it for y, that would have been the
Then it'll give us the
inverse,
x
right?
value of
So, yeah, if we solved that for y, we have the inverse. If we took the derivative, that's what we get right here. So this is really the inverse's derivative. Maybe the problem is now we've got 3y plus 2 here. We're supposed to find it at 2. That's really a value, an x value.
the x value of the original function.
Yeah.
Okay.
So we got to come up here and find f of 2.
To get a y value?
To find the y.
Oh, to plug in the y into the
Yeah, 'cause
derivative
this-
of the inverse.
Yeah, so put 2 in there, you get 8 plus 4 minus 1, you get 11. Right, so this, we really want to put 11 in for y, because that's what y is, right? That's like finding y of 2. Find the y when x is 2. So then here, we put 11 in here.
So y2 is the same as f2? Up there.
Yeah, because f of x is y.
Fine to write up.
Right? We're replacing, when you write functional notation, we're replacing y with f of x. So f of x is y. So you say f of 2, you're saying what's the value of y when x is 2? So we get the y to be 11, so this, they said a was 2, whatever, we want to do is plug 11 into this. So we'll get 1 over 3 times 11 squared plus 2. That would be 1 over, is that 121 times 3? No. 363, 365. No, is that the right answer? Think so? You check.
120, is 11 times 1, 120?
No, I mean the book says it's right.
Oh. Oh, I'm not sure.
I'm sure, because what if we did that whole thing, we're wrong?
Yeah,
We're not helping ourselves, are we?
exactly.
So 3, 6, number 3. We should always check our answers.
I don't know the answer. Maybe wrong.
Yeah, we could be wrong, which would be interesting. We figure out what's wrong with what we did. Number 3 is 1/5. So there's some flaw here. What's wrong with what we did? We switched the x and y. If we could have solved for y, we would have had the inverse. But we couldn't solve that for y to get the inverse. So we went ahead and took the derivative. And whatever y equals is the derivative. That should have worked. Seems like.
So why don't we choose this way to change?
It just said we wanted to evaluate. Number 3 said find the derivative of the inverse.
Oh.
So to find the inverse, you switch the x and y. So that's why we switched the x and
You have to
y.
then solve.
But then, that's true. To find the derivative of an inverse, first you got to find the inverse. You switch the x and y's, and then you solve for y. That's your inverse. So that's why we switched the x and y. Right? We couldn't solve for y, so then we hypothesized, I guess. Maybe we could just take the derivative of this, and that would be the derivative of the inverse, and it turns out it's not. So now we got to try something else. Right? Because you're not going to sit down every time and do everything the right way. You may do something wrong, you got to figure out what's wrong, why didn't it work, go back and try something else. Now, the derivative of an inverse of a function, if g is the inverse of f, then g prime of x is 1 over f prime of g of x, right? So it's saying g prime, if g is the inverse of f, then it says g prime of x equals 1 over f prime of g of x. Right, you're right. On problems like the other problems, you said you could easily find the inverse, right?
Yeah, just by flipping them.
Yeah, but this one, when our function is, what was it, x cubed plus 2x minus 1, we couldn't easily find the inverse, could we? But if we did find the inverse, right, it would be, the derivative of the inverse would be 1 over the derivative of the function with g of x, g of x. So, when they say do it when a is 2. So if we came in here, we did f of 2, we get 8, 12, 11. Right? And this same type of thing we're saying before here, right here, when x was 2, y was 11. Right? So when x is 2, y is 11. So we want to do it 2. So f of 2 is 11. What's that mean? The g, if we're trying to find the, for this, we're going to do the derivative. We want the derivative of the inverse at 2. So that's going to be 1 over f prime of g of what? If g is the inverse of x, of f, it'd be g of 11. Right?
Because the inverse should take 11 and make it 2, right?
Yeah, if you find the inverse, you switch the x's and y. So if the point 2, 11 is on the function f, then the function g should have a point 11, 2. Right, so if we wanted to do it at 2 for x in the original function, then we need to use 11 for the x and the inverse.
Which means
For this formula lets us do this without having to find the inverse. Right, now we also want to find f prime of x. Right, what's the derivative of this? It'd be 3x squared plus 2. Right, so
But you have to have the inverse to plug it into that, don't you? Because that's your g of
Which
11.
function is considered g of x?
well, it's gonna
let's, okay, this is what we're looking for, right? G prime of 2. That's what the thing's saying. It's saying, they gave us the function x cubed plus 2x minus 1. We want to find the derivative of the inverse of a, where they're saying where a is 2. Right? So we want to find the derivative of the inverse of 2. So if we follow that formula there, okay, it's going to be 1 over f prime of g of x, or f prime of the inverse. So it's going to be f prime is this 3x squared plus 2.
So then you put,
So where do you get the g of x function then?
How we change the g, how we get a to be x.
where did it say the answer was? One fifth?
I might have been looking on the wrong thing. That doesn't, I don't see how we're going to do 1/5. All right. So guys, here's a perfect way where we could work this through. This is good. Let's say at number 1. Casey, you said you were able to do number 1, right?
Yeah.
Number 1 was f of x is x cubed minus 1. So let's see if we can make this. F of x equals x cubed minus 1. We want to figure it out when a is 26. So you went ahead and found the inverse. You switched the x and y. So x equals y cubed minus 1. So y cubed equals x plus 1. Right, then you take the cube root, y is the cube root of x plus 1. So we figured out the inverse is, I'm going to say x plus 1 to the 1/3. Because then we want to take the derivative of the inverse. Right, we're going to take the derivative of the inverse with respect to x. So it would be 1/3 times x plus 1 to the negative 2/3. Or it's 1 over 3 times x plus 1 to the 2/3. So then we want to figure it out at 26. So we take the derivative of the inverse at 26. We get 1 over 3 times 26 plus 1 would be 27 to the 2/3. Right, cube root of 27 is 3. 3 squared is 9 times 3 is 27. We get 1 over 27. Right, was that the right answer? It was. Okay, so I'll check it. Okay, so let's see now, if we try to apply that formula. Okay, the formula said, maybe I'm writing that down wrong, I don't think I am. Let f be a function that's differentiable on an interval. If f has an inverse function, g, and g is differential at any point or ever, the derivative of g at x equals 1 over f prime of g at x.
Hey, real quick,
Yeah.
I did it a different way. I still got the right answer. So what I did was, I plugged the 27 into the inverse without taking the derivative of the inverse. So
You
then
plug the
get
27 into what?
into the inverse.
Okay, so you plug 27 in there, you get
Yeah.
3.
And then I plugged the 3 in to the derivative of the function.
3 into the derivative of the function.
Yeah, so
Of
the
the
derivative
original
of the function,
function.
of the original function, which is 3x squared. And so I put 3 into that, and then you still get 1/7. And that's how I did number 2 as well. And I also got the right answer there.
So you are plugging 26 into the inverse.
Yeah.
Okay, but the question comes in, if you can't find the inverse,
Yeah, so
oh, I think I just figured out we're doing wrong on the other ones. Thanks to your insight there. So look, if we try to use this formula on this, right? Let's say like, if we didn't find the inverse.
Okay.
If we didn't find the inverse, the function was x cubed minus 1. Right? We're trying to figure it out when a is 26. So if we're following this formula here, we want to find g prime, or the derivative of the inverse of 26, is going to be 1 over the derivative function at g of 26. So you're actually using, in a way, the formula, but you're doing it a different way. And you're saying you take the derivative here, right? You get 3x squared.
Yeah.
Okay, now to do this, we got to find the derivative of the function at g of 26. This is backwards. This 26 is really the y in the original function, right?
So we have to find out what x
Right, 'cause-
is. 26?
Yeah. If you've got a function, you got x and y. If g's its inverse, then those switch. All right, so when they're saying this 26, if this is 26 is a x in the inverse, if it's an x in the inverse, it's really the y of the function. So if we take that original function, set x cubed minus 1 equal to 26. You add 1, you get x cubed is 27. Take the cube root of both sides, you get x is 3.
So you have to find out which x value makes.
Well, you know which x goes with that for y. So they're really telling us the y
Yeah.
thing. They're telling us the x and the inverse. So if x is 3, f prime of 3 is 3 squared times 3, it's 27. So this is 1 over 27.
Because let's do it on the 3.
So if we go back to this one, okay, the problem we're running into here is I'm assuming this a is a 2 for the x. It's not.
It's a 2 for the y's.
Yeah. The a is a 2 in the inverse of the function. Right? So that means it's an x in the inverse. That means it's a y in the original function. So if it's a y in the original function, if we come here and take this function and set that equal to 2, we'd have to solve for x. And if we subtract 2 from both sides, we get x cubed plus 2x minus 3. What values for x would make that work?
It's not solved.
I don't think so. It's a coefficient test here. Add the coefficients, what do you get? What's 1 plus 2 minus 3? 0. That means x equals 1 is a solution. Or if we put 1 in for x, that equals 0. All right, then I'm thinking the other two are probably complex, imaginary ones. But we could always do synthetic division real quick just to check this. I could do 1, do it into 1, 0, 2, negative 3. Right. This becomes 1, multiply. This becomes 1, multiply. 3, 0. Right, so since that's already x cubed, this would be x squared plus x plus 3. All right, if we tried to solve this, if we did the quadratic formula, we'd get the opposite of b plus or minus the square root of b minus 4ac. We have the square root of a negative number. So 1 is the only solution. So that means 1 is the x of the original function. So if we take the derivative of the original function and put 1 in for x, what do we get? 1/5 is the answer it should be. So we were using the formula right. Our flaw was when they give us that a, that's an x in the inverse, which means it's the y in the original function. Which, Bailey, when you said on this one, what you did was you plugged, you switched these here, and you said you plugged it in here, right? Wait. Or did you? What did you say?
Oh, wait, sorry. I was plugging the a into the x value for the inverse.
Yeah, and when you plug in for the x in the inverse, that x is really a y in the original
Yeah.
function.
And
So
see,
that's what made me
I
think.
knew that, but then I was having the algebra issues, and I was also trying to solve for y when I needed to do that first.
Now, if we go back to this, okay, when we tried to do this one this way, this probably still should have worked if, okay, we didn't have that minor flaw here at the beginning. All right, this is 3y squared. 3y squared plus 2 we got down here. So this looks familiar, doesn't it?
That's not our a. The a is the x, right?
Right, but see, that's the same thing we got here. Right, in the formula, it's f prime of g of x. F prime is 3x squared plus 2. We've got the same thing here. We just had to figure out, okay, we were assuming this 2 was the x in the original function. That's the x in the inverse. Right, so if we went back, like I did the other problem we figured out, on the original function, that went with 1 for x. If we plugged 1 in there, look at that, we get 1/5. So this works as well. So this, you guys, it's good when you work out a problem. You don't want this to happen all the time, but when you work out a problem and you don't get the right answer, if you can go back and go through what you did and figure out what was wrong. And really, there was nothing wrong with our thought process here, or actually it was the Dolphins said to do this, right? He's listed this. This was a perfect thought process. The problem was we mistakenly assumed that the A they gave us in the problem, when they said do it where A is 2, that was the x in the original function. It wasn't. That was the x in the inverse. So if we use the right x in the original function, we get the right answer.